The solar supply chain threatens our climate goals, with recent disruptions, including the pandemic, problems with international shipping, and import seizures due to forced labor in China. At the heart of these challenges are the silicon wafers that power 95% of the world's solar panels. Now, because we can't compete on cost, wafers have not been produced here in the US since 2016. And in fact, manufacturing silicon wafers is so complicated that over 90% of wafers available for purchase globally are produced by just 2 overseas companies. At Leap Photovoltaics, we're developing a groundbreaking manufacturing process that eliminates wafers. We go directly from refined silicon to finished solar cells. And this approach links the pieces of the solar supply chain that already exist in the United States to create entirely American-made solar. Our breakthrough combines recent advances in additive manufacturing, coating technologies, and the formation of electrical contacts in commercial silicon solar cells, and enables us to retain the performance and reliability of silicon solar cells while consuming 90% less silicon and 70% less energy than wafer manufacturing.
Existing alternatives to the wafer supply chain either try to make wafer manufacturing simpler or to replace silicon with thin film materials. LEAP projects lower cost and better performance than kerfless silicon wafers, higher efficiency potential than traditional thin films, and better reliability than perovskites.
Customers we've spoken with will not accept these trade-offs, but they're eager for the local supply chain and cost savings offered by LEAP's technology. They've outlined 4 key metrics to prove we have performance equal to wafers. Specifically, we can absorb sunlight as well as wafers, and we can collect the electrons that sunlight generates without losing too many to defects in the silicon, parasitic current pathways, or resistive heating. In the set phase of the American-made Solar Prize, we demonstrated optical absorption equivalent to wafers, validated by measurements at Livermore National Lab. We are now working on scaling up our process at the Washington Clean Energy testbeds. We demonstrated material quality equal to wafers with bulk and surface electron lifetime measurements from UC San Diego. These collaborations and the American-made network were critical to achieving our goals, providing expertise and equipment for additive manufacturing and advanced coatings. Winning the ready phase also enabled us to move into a new expanded lab space. There, we are installing key equipment to scale up and improve our fabrication process with the help of our partners, Materials Research LLC, who have over half a century of collective experience with these specific coating processes and equipment.
I'm Matthias, a co-founder and CFO of Leap Photovoltaics. Our team brings a wide diversity of experience. David spent 15 years working with academics, startups, and major solar manufacturers to find a way to make the best solar cells here in the United States. I have executed dozens of financings for high-growth technology companies and previously worked on the engineering side developing large-scale infrastructure projects.
I'm Rajgopal Ramesh. I recently joined as Leap's full-time in-house engineer, and I'm excited to use my solar and additive manufacturing expertise to push our production-ready prototype over the finish line.
Leap's advisors have decades of experience in solar R&D and entrepreneurship.
Our initial goal is to sell to US module manufacturers, who already purchase about $500 million of solar cells each year. We will work with these customers to build their market share in the US and expand into overseas markets, projected to grow to $40 billion per year by 2030. Our customers are currently deciding between overseas solar cell suppliers based on price differences of less than 1%. We can easily offer discounts more than 10 times larger with a secure local supply chain. We already have a signed LOI for our first 550,000 cells, and we continue to build our pipeline of early customers.
We are trying to source every single piece of material that we use in our solar panels from the United States. And right now, we cannot source solar cells from the United States because they're not made here anymore. We are excited for the opportunity to be able to source our solar cells once again from the United States.
Success in the American-made Solar Prize will enable us to realize our vision. In the Go phase, we will continue to build our in-house engineering team. We will add collaborations with NREL and Arizona State University to produce high-performance prototype cells ready for scale-up to pilot production. The aim is to deliver on our LOIs and test cells with customers in 2023. Demonstrating performance with these early customers will position us to bring solar cell manufacturing back to the US. We aim to build America's first ever gigawatt-scale silicon solar operation by 2025 to truly leap into a new era of US solar manufacturing.